Right. So what was the this one is like a we discussed that pushing the start has to start the motor, and pushing the stop has to stop the motor. And in case if somebody has started the motor, and if he left the location, when the level becomes low, it has to stop. That's what we discussed, and that is what the program also we have done. I am okay. Do you want me to repeat the same, or do you want me to proceed to the next? You can reply to me, and then accordingly I will do it. Either you can send a message or you can talk to me. So I'll wait for your message or talk to either repeat this or proceed to next. Right. So I got a message that I need to repeat. Yes, no problem. So like we wanted to make sure you understand correctly. Right. So I wanted to clearly again see, even if I can able to make you understand one example clearly, I am happy. Instead, if I am rushing, if I am going through without you making you understand, then it's of no use. Right. So we have the assume in your like in your home you have the motor which is going to let us say pump a tank outlet, and it has the start button. So green color start push button, meaning when you push it will be 1, and when you release it will be 0. So the same way, like I'll make a this also to make you easier. Right. So, and then you have the red color button, which is a stop push button. So when you push it, it will become a 1. When you release, 0. So the requirement is like when I push the button and release, the motor has to start. Even if I release the button, the motor should keep continue. It should not stop. Right. Basically, we want to latch it. Once you push and release, you latch it and keep running the motor. And if I wanted to stop it, I need to go and push the red color. One time push and release, then the motor goes stop. Right. So this is the basic function of normal motor what you have in your home. Now what we have added is, when I push and release the green color button, the motor may be running. While motor is running, let us say we left from the location, and the tank level is slowly coming down from a top, slowly coming down. Once it comes less than this location where we have the switch, then we wanted to stop the motor, because the tank low level we want to stop it. If we don't stop, what will happen? If we don't stop, there won't be any water, motor only be running. Without water, if you run for a while, the coil will get heated up, and then the coil will get damaged. So to avoid the damage, what we do is, when the level goes less than the level switch, it we will initiate the stop for the pump. That is the logic we wanted to build actually. Right. So now we go to the program. So before going program, the address. Let us make a address. The first one, green color. Let us make a the address is I001. This is the first channel. In a PLC, we have connected on the first channel I001, and then we have the red color button, and assume that this is connected on second channel of the PLC. So it is a I002. It's a second channel, and then assume that the level switch is connected on the channel number 3, I003, right? So as you all aware, this is a push button switch, and this is also push button switch, and this level switch. Anything called as a switch, we used to say as a digital inputs, because you are going to give, say, a start the pump. What you're going to say, you're going to say start the pump to the PLC, because this is for the PLC is the input, because it's listening your word via the wire, and you are going to push it and say I wanted to stop it. Again, you are saying PLC has to listen to take any action. So since it is listening, it is the input. The same way, we have a level switch, which is I003. This level switch can say to the PLC, hey, when there is no level. So again, since it is saying to the PLC, it's a digital input. Okay, now coming to this motor. The motor is a digital output, because the PLC has to say start now. This gives a command, this gives a power to the motor to start. So it is something coming out from the PLC, so it's a output. So anything goes into the any information going into the PLC is an input, anything coming out of the PLC is a output. So the motor control is a output, because PLC has to give a power, is just to give out something to the motor to run, so it's output. Whereas the other three, they have to give information to the PLC to take some action. That is why from the PLC point of view, it is an input, and the motor from the PLC point of view, it's an output, right? So now we can say, okay, let us define the address of it. Like assume that we have connected the assume that we connected this the motor on the Q001, which is the first output of the PLC, right? So now all of us knows the IO address of the various component, we know it. So once we know the IO address component, now like something like a 50% of understanding is clear, right? So now we will go to the programming part. So far it should be clear. If it is not clear, you can let me know, so because that is understanding is very important. So now I will give you once 1 minute now, you to reply to me. If you understand very clear, we are okay. If anyone in the group, hey, I did not get the point and did not understand, you can text a message or you can talk to me. If you wish, I can repeat n number of times, that's not a problem, but we want to make sure you understand correctly, right? So from now 1 minute, I will wait for your feedback. Okay, so I understood like the simulation. Anyway, we will be doing the simulation today again. So when we are doing again simulation, we will go through it. Okay, the as see like as in terms of the process requirement, like what I described the process, that's supposed to be okay. If that is okay, then now we will jump into the program, and I will make sure you understand correctly, right? Fine. So now we have the we have a input of I001, we have input 002, we have input 003, and then we have a Q001. This is the motor output. So input 1, input 2, input 3, and then motor is output 1. Now, once we get this information, we should be clear to go ahead with the programming, right? So now I am in the programming PLC programming software, right? So as all of you know, we understand that we have a 3 digital inputs, right? The first digital input is the first digital input is like the start button, green color start button, and second input is red color stop button. Third one is the level switch, right? So let us try to let us try to do one by one. Right. So the digital input, since we know it's all of them are digital input, because push button is like you are pushing means on, releasing is off. Pushing is on, releasing is off. So since it is a pushing is on and releasing is off, only 2 state. So this is a digital input. So now I wanted to connect to the digital input. Like let us say, click on the input. I clicked on, like you can keep watching my mouse. Like I brought nearby the digital and below digital input there is an input. I selected by clicking on it. So now, since I clicked on it, like you can see with my mouse, that input block is attached. So I'm going to click here in the screen. 1, 2, 3. For me, it is enough. I don't want any other input. So I need to press escape, because still you can see my mouse having that input block attached. So I will say escape. Right. So now we have 3 inputs. As we discussed, like a first input is a green color push button. So I double click on it. I will say green. Just for our understanding, I will say green color push button. Because we said I001. This is the first input on the PLC. Like in the PLC, this is a PLC part. So this one, like I1, here only we have connected the input. I assume that because you are not seeing it physically. So what we are doing is like from the switch, you need to bring a one cable, and that wire we need to connect here. Once you connect it here, when you push, the signal will come here in the I1. When it comes here, it will light up. The light will come up. That means you pushed it, right? So I took a one digital input. I have assigned to this input 1. See, that is what you connect. Like the software component has to be connected to the hardware component, right? So I am taking the whatever I am seeing on my cursor. This is a software component. Is a software. What I am doing is I am attaching to this pin, like I1 pin. This I1 pin only you connected the physical the push button switch. So I have connected by I001 because given address 1. So once I given 1, that means this will look for this pin, right? That's how the connection between the software and the hardware. Now you have another hardware which is a red color push button. So I am taking another soft button, like a software. I wanted to connect it to the pin. So this is a red one. So since I have given a address I002, the 2 is this 2 pin. In the 2 pin only you are connecting the wire. So it is very clear. We are attaching the software directly to the pin, right? So I002 connected. Now we have the I003. So this one is connected to the pin number 3. So now I will, it's a level switch, right? So basically what we have is we have three inputs. So three inputs, I have taken a three input block and attached those blocks to the pins, right? So far it's supposed to be clear. If anything is not clear, you can ask me. So I will wait for a 1 minute from now. You can ask me, you can text me in case if you do not understand. Yeah, so looks to be it is clear now. So we will go ahead further. Right. So the digital inputs we have connected. We are very clear. We have taken a software component from digital and we have attached to the pins of I1, I2, I3 where we have physically connected the switches. Right. Now the remaining part is like a output. So I clicked on the output and it has come. I clicked on here. The output has come Q001. In this, like the motor is connected to the digital output on the Q1 on the PLC downside. So that's why the Q1001. So the motor you need to bring a cable connect on Q1, which is a Q001. So if you do so, that means whatever the output comes here, it will drive the motor directly. So now right now it's open. It is showing it won't operate the motor. It's like a normal switch what you have in your home. If the switch is off, nothing can run actually. If the switch is closed, the motor will run. That's what the symbol it is showing. So right now it is open. It won't operate. Right. So we have connected that software block, which is the output block. The output block, remember, like the motor is output. So it's an output block. We connected to the Q001. So if you want to give a name, we can give a name pump. Right. So this is the pump command. So now we have taken three inputs and one output. So that is what from the PowerPoint. From the PowerPoint, which shows like we have a green color push button, red color push button switch, and then the level switch, three digital inputs and one digital output. And we configured that the digital input and digital output, right? So now we are trying to do the programming part. So IO part is we have done. The logic part we need to develop, right? The logic part is like the requirement is like what we said, when you push and release, the pump must be keep running. Though you release it, it must be keep running. So like generally when you are pushing the button, it gives a signal. When you release it, it goes off. Like if you want to check it, I'm going to do the simulation now. The simulation part is like whatever you have, this is a program. Either this program you can download into the physical PLC and then test physically. Otherwise, you can do software simulation also to make sure this works as expected. So what you can do is like you can go to the tools. Under the tools, there is a simulation. So you can click on this simulation. I clicked on this simulation, right? So now we have all of them are off. Like you can see like the digital input and digital output, all of them are off, right? If I give the input physically, so what will happen when I push it? So when I push physically, this goes on. Okay, I think it won't give a simulation because there is no wiring. Is what I think so. Right. So it's not giving a simulation on because there's no further wiring. So let us do the wiring and then test it. Actually. Right. So as we understand, the when you push it, it becomes a one. When release, zero. When you push, if I connect directly, for example, let us say I'm going to connect directly. I'm taking the wire. This is my start. I'm directly connecting. Like it's a switch in your home. So, and if I'm connecting like this, what happens? So let us see. Right. So now I am pushing it. I am holding it. So since I am holding, as long as I am holding, the motor will be on. Once I release my button, it goes off. The motor is off. So that is that we do not want actually. Like you can see, I am keep holding like the output is on. You can see the input is red color and the output also red. That means like when I am pushing, the motor is running. Motor is like a switched on. But if I am releasing my hand, it goes off. So that's what like it happens. But what we need is we wanted to make sure when I push and release, we want the motor should be running. So basically what we want is we need a some latching mechanism just to latch. Once I push and release, it has to hold. It has to hold and keep running. So for that mechanism, what we want is we want a set reset flip flop. That what it does is it holds the signal. So as we discussed yesterday, you can go to the miscellaneous. In that you can see RS, so latching relay. So you can select this. I bring here, and then if I want to do the wiring, either you can take the wiring or if you bring the cursor, it will highlight. So once you do start doing a programming, you will become expert. So I'm giving this connection, and then I'm going to this one. Like there's a two LED I connected on set. You can see here the bottom is a R and the top is a S actually. You can see set. In a set, I am connecting because when I'm pushing the green color, I want to set it. Right? That's the reason why I'm trying to R is that is a reset. I wanted to set it. I want to set the motor running. So this is what exactly we need. Let us try to see the simulation how this respond. The last time we have seen without this set reset, we connected directly. What we understood is as long as I make it on, the output is on. When I remove the button, then the motor goes off. That we do not want. We want when I push and release, it has to run continuously. Right. Let us simulate this. So I am pushing it now on. I am releasing it now. So I pushed and released. But though I pushed and released, right, still my motor is running. Right. You can see the physical output is there. That's what it's a latching mechanism. Like in your home, how you do, you push green color and release it. You are not going to stay there by holding the green color always. You push and release, motor will run. That is what we achieved now. So we have a set reset flip flop that holds this the information what you sent and then keep the motor running. Right. So now we wanted to, okay, this portion is clear. If it is not clear, you can let me know. I can hold for one more second and let me know if you are not understand, right? So from now I will hold for 1 minute. So, right, we understood, we presume that it is clear as of now. Right, we'll proceed further. So, when the green color button is pushed, it is by using the set reset flip flop, we are making the output on. That is clarity to everybody. So now we wanted to stop it. So to stop it, whenever this is a red color button, right? Because I002 connected this block is connected to the input 2, the I2 pin, where you connected physical your red color button. So when I push the red color button, we need to make it stop. That's the requirement. So what I do is like I wanted to connect this block into the reset. So this is like a set reset flip flop reset leg. So the moment when it gets the high signal on this reset, the output will go for 0. Right? That is the set reset flip flop function. Set reset flip flop is like in a set, if you give a 1, the output will come 1. When you give a 1 on the reset, the output will become 0. Those are set when you set it, and then when it becomes a 0 when you reset it. So now I use that opportunity and I am connecting my red color button to that leg, right? So now let us check the simulation and see if it works the way how it is expected. So I'm going for simulation. Right. So I'm going to make it on one time push and release. So when I push and release, you can see the motor is running, the pump is on. You can see the physical output on the PLC Q1 is closed. The red color is coming up, is closed. Okay. Now, while the pump is running, anytime if you want to stop it in your home, you go and you push the red color button, right? The same thing I'm going to do here. I'm going to push and release the red color button. So since this button is connected to the reset leg, the output will go for off, right? That's what we are expecting. So I'm going to push it one. I pushed and released. So you can see the motor gone off and the output also open. So the motor is stopped, right? So this is a simple start stop using the green color the like one push button to start, one push button to stop. So we have tested the simple start stop for only the buttons, but we need to add the another logic also. Whenever the level comes low, we want to stop it, right? So again, I will stop now here and make sure you understand correctly. If not, something is not clear, you can text me. I will hold for next 1 minute now. Right. So I presume all of you understand correctly. So I will go for the next one. So I'll go for the normal configuration. So now, see, basically what we want is like it's a if you talk in a statement, the statement is like whenever I'm pushing and releasing my green color button, it has to start. The motor has to start. The another word is like whenever I am pushing the stop button, or this says clearly, whenever I'm pushing the red color button, or when the level switch become low, then the motor has to stop. So it's a very clear. It is not something like we need to have a like a the powerful brain or whatever. Like a statement itself, you can understand actually. When the red color button is pressed, or when the level switch becomes low, if anyone comes, see in a, what gate you use. That's what you need to pick up the gate, correct gate actually. The picking up the gate is as per your brain actually, right? It's not that like somebody will come and say, hey, you have to pick up this gate actually. So we understand when a stop button is pushed, when the level switch become low, I wanted to stop this. When anyone comes, we wanted to stop the motor. That's the requirement. So what we do is like I delete this line because we want to make the OR gate. So I'll go for a OR gate now. So OR gate is under a basic. So I'll click on OR gate. I'll put here. So now I will draw a line from the stop push button and then the level switch. So if any one becomes high, then output will become high, and this I connect to the motor. So basically what we are trying now is, if any one of this condition occurs, we want to stop the motor. That's what the logic requirement, that's what we made it, right? So now let us check this simulation again, right? So as we all understand, when I am pushing and releasing the green color button, motor has to start. So you can see the motor is running on, the pump is on, as well as you can see the output is become energized, like closed. The switch is closed to start the motor. Now, if my stop is pushed and released, we want to switch it off because I want to stop it. So now we can see I pushed and released, the output become off, and you can see, notice here the output is open. So it is stopped. Now, the second condition is like what we discussed is like when you make it on, I pushed it and released on, you left from the home or you left from the location. Then what will happen? Though you are not there, the level switch keep monitoring the level. When the level becomes low, then it stops the pump, right? So again, I'm doing it like I'm starting this by pushing the button, and then the tank level, when it goes low, it gives a stop command, which gives a on one. Once it is giving one, this stop. Basically, the level switch does the job what the stop can do it, right? The stop and the level switch both are in a parallel line, and if any one comes, then motor has to stop. That's what we made the logic. That's how this logic is. So by this logic, you can say you can protect the motor from when the tank level is low. We can block the motor starting so that you can protect the pump from coil damage, right? So I hope it is clear, but if it is clear, you let me know, I can repeat. That's not a problem, because we want to make sure you understand correctly. Otherwise, like going forward training, just time, killing a time is not a worth. So hope should be clear, but again, I will stop now for 1 minute and let me know you are clear. Right. So how can we connect the input and output? Right. The how can we connect the input output? This is a question. So right, I'm going for off. So basically, I can show you my so I can show you my the video, my this one. Wait a ಇದು ವೈರ್ ಇಲ್ಲ ಇಲ್ಲ ವೈರ್ ವೈರ್ನೇ ಒಂದು ಪುಷ್ಪಟ್ ನೋಡ್ರಿ. Right. So I'm going to show you like a. So you asked a one question, but there is a two. I presume this is a two question. So I'm going to show you the two answers. Maybe like one of the answer will reply your question. So I'm going to do now. Right. So, yeah, camera away. Hmm? Oh, is that- Right. So you may be seeing me now. Right. So this is the same PLC what you are talking about, right? This is what you are seeing in the physically you are seeing there, and I have the one push button switch like a red color push button, the same thing what we are discussing now. So basically what happened this wire, like when you push and release, in a one wire I give the 24-volt DC, the input, and when you push here like you can face, you can give when you push it, the other wire, it goes into the terminal block. You can see the same terminal block. Okay, if you notice it carefully, you have this terminal block here, and then it goes into this the terminals, you can see it goes and connect on the bottom, and then we screw on it actually on top actually, right? So and then when you tighten it, then it goes attached here you tighten it, and that's how it connect the physical inputs. That's what we are saying, right now you can see this red color push button connected on this input, and when I'm pushing this, the input will come here and light glows here, and that's what one. So that's what we are using in our logic, right? So now, if I connect this into the I, let us say for I 4, like a input 4, I am connecting, right? Assume that I am connecting on a input 4. If I am connecting on an input 4, how do we connect it to the input 4? Let us show you now. See, for example, let us say my the like whatever you have seen, the red color button, it is going and connecting on the input 4. Assume that way. Like, see, in this like a input 4 I am connecting. So I wanted to connect my software block to get data from I4 input 4, where I connected our red color button, what we have seen just before. Then what we do, double click on it. When you double click on the block, it gives you option to choose. So I4, let us say if we connect this input to I4, then you choose I4, like a red color button, right? So I'm the red color one, I'm double click on the red color one, and I can click here and I can choose I4, where I have connected physically, right? For example, level switch, I'm connecting on a channel, the input number 8. Then double click on it, then click on here, then select I8 and say OK. So this way, what we are doing, the software component, we are connecting to the hardware by choosing the address, right? And the same way, like a motor, let us say motor, I'm connecting on a Q4, like in this terminal block. Then double click on the Q, and then choose the Q4, the address Q4. This once you say Q4, that means what we are doing is the software component we are connecting to that specific pin. Now, if I go for a simulation, so when I make it on, you can see the Q4 become ons. See, what we have done is now instead of Q1, now Q4 is coming because we connected that software component to that pin. Now your motor, you need to connect on that point. If you connect a motor on this Q1, it won't start. So you have to connect a motor on the Q4 physical hardware, right? So the input assignment, output assignment is based on what you double click, and then you can choose double click on the block, and choose what input you have connected and say OK. Right? The same way, like the output also, double click on it and select what terminal block you connected. That's what you need to select. Hope I have answered. If I did not answer correctly, then you let me know. Banu, is the explanation? Did I answer for your question or not yet? Your first question did I answer correctly or still you need some clarification? You can say, you can type it so that I can understand.
Sir, how can we get wires in software, sir?
Say again. How can we?
How can we select wires in software by connecting
Okay.
input and
How
output?
can we? Yeah. How can we connect? Right. So, like you can go here. For example, let us say I have a block. Like say I have one block input block. I have a, let us say I have one output block. Right. Now your question is like how do I connect this wire? So in the left side, if you see in the left side, the first one, second one, third one, there is a connector like the small like the up arrow and down arrow. So you click on it. Once you click on it, see my cursor. We see my cursor. There is an arrow up and arrow, and there's a wire is there. So now you come close by the block. When you come close by that small connection, like see there is a small projection. That pin, that is basically a pin. That pin you bring it here. Once you bring it, the blue color comes and a chain comes. Right? Once the chain comes, if you have a mouse, then if you have a mouse you can click, but you should not be leaving clicking it and then move the mouse. Don't leave the click. You bring it, and then you bring it until you see another chain. And now still you should be click hold and that the click what you use right and the right click, you keep holding it, and now you release it. Once you release, it will connect by itself. Right? So this is how you can connect the wires between two blocks. I hope I answered. If it is not answered correctly, you can ask me again. And you can try parallelly. You can try, if you are trying, you can try it out and see it's really working. If it's working, okay, very good. If it is not working, yes, we can repeat. Right. So there was another question. Will level switch on automatically when the tank is full? Will level switch on automatically when tank is full? Is this question is like just to understand correctly, will the motor start automatically when the tank is full? That's what the question. That's what I understood now. If my understanding is correct, yes, you can do it. Level switch, like for example, okay, let me try to for like this is like what we have done. The program is start the motor and stop the motor automatically when there is a low level. But there is a option, there is a program, there is a requirement when the tank level, they may not be required. You don't require, hey, I don't want to stop it. Stop is always I can stop. But if my tank level is high, if my tank level is high, I want to start. I wanted to start the motor. Like for example, like because my tank has become full actually. So then generally what they do, they used to install the same level switch on top side. On top side they install. So what will happen? Like this the same concept. When the level is high, when the level is high, it gives a one. When the level is not high, it gives a zero. right? Now let us assume when I start this, when I push this button, we want to start the motor. When I push this red color button, we want to stop the motor. But the same way, when the tank level is high, we want to start automatically. Because the tank is high, it may overflow. The tank will overflow if we don't start the motor. If that is the requirement, we can see how that can be achieved in the program, right? Right. So now I'm going to delete the bottom one. Oh, in the top, it's a very simple concept, the same concept. Just if we spell out, when I start the motor, okay, let us delete this. Okay, delete this. When I start the motor, when I push the green color button, it has to start. That is already we have done. When I push the red color button, it has to stop the motor. Already we have done. So now, pushing a green color, starting the motor, pushing the red color, stopping the motor is clear to us. Now let us talk the same word just to express what is the gate required. The gate requirement is like whenever I am pushing a start, it has to start, or if the level becomes high, it has to start. So by wording like it is not that when the level comes and when you push. No, it's not the way actually. The requirement is that when I push the green color push button, or when the level becomes high, anyone comes, we want to start the motor. Or so if anyone comes, it has to start. So now the whatever we assume the word, the same word we can implement like delete the set, right? So now what you can do is like you can choose the input. Assume that we have connected on the 3 address. I am clicking on 3. This is my level, the high level switch. So when anyone comes, like when a button pushed or when the level becomes high, if anyone comes, then we wanted to start the motor. This is the requirement. So anyone or like so we'll take a OR gate, put a OR gate here, and we can connect this one and this one, and then the OR gate output can come to the set. So basically what it is doing, either you push the green color button or the level becomes, like I can say, I can give a level. When either you push the green color button or the level becomes high, anyone comes high, the output becomes high, it goes and set the motor and motor runs. And then anytime if you want to stop, you can push it, you can stop the motor, right? Let us try to simulate and see. This is a simulation. So I'll go for off, right? Now the motor is not running. So what we are going to do is like we are going to simulate the input. Let us see, let us visualize what happens. So I slightly move it up, right? Sorry. Right. So now I am pushing the start and releasing it. So one time push and release the green color button. See, the Q4 is on, motor is on. And we are coming for the red color stop, red color button, pushing and releasing. I pushed and released, motor gun off. Now let us assume that nobody is starting the motor. The tank level is slowly going up in this tank from a mid to the slowly going up. The moment it touches the ball, like what you see the float, when the touches the float will go up slightly. When it goes up, we get a 1. So once it gives a 1 signal, which is the this third level switch where you connected, it becomes on, and then immediately you can see, even if it stay on or even it go off, the motor starts continuously, right? So now what is happening, either a green color push button pushed or the level becomes high, anyone comes high, you can start the motor, and pushing the red color button, it stops the pump. Like I'm going to push the red color, it stops. So now what we have seen is like we have seen the manual start, automatic stop, and then this example is automatic start, manual stop. That's what we have seen, and we can combine both also. For example, like I wanted to start automatic also, I wanted to stop automatic also possible, right? So I hope this explanation should be clear. So I wanted to get your feedback, like if anything is not clear, you can text it now. So I'll wait for a 1 more minute to get your feedback. So it looks like everyone understand. If you have if you want to ask me further, you can either text it and you can talk to me. That's not a problem. So now we'll go to the further step. Right. So basically now we can combine both also, like automatic start and automatic stop also can be combined in this. Like it's the same thing like what we have done last time. So we can go here. You can break this line because we have a stop button. But what generally what they do is like they put a two-level switch in a to achieve it. See, it's not only programming part is like a one part, but in a physically also the you have to put a the switches and motors whatever you wish. So this is basically like in a plant. Normally they decide what is their requirement. Sometimes their requirement could be they don't want to start the motor, only the automatic start. Some people they say no, automatic start and manual start. We don't want any stop because somebody will take care or whatever. Something they will. There must be always some demand, some specific requirement, and somebody will say no. My when the level goes low, the motor has got a damage and everything because some motor even with low no like a low level they will have some kind of the locking mechanism like where like it can switch to another tank or some logic they will have it actually. So it is based on the site requirement. It is not like what our requirement. So if the site requirement is, hey, I want to start automatically, I want to stop automatically, then they have to go to this mechanism. There is no other option. They have to have a two switch. One is low level switch and then is high level switch. So when the low level comes, it stops. When the high level comes, it starts. In parallel, they also can start. If you do not want to start, you would not want to stop manually, you can take it out. Only the level switches will stop. Every combination is possible, right? Just to visualize this one, like the logic, what we do is like we have the red color push button, which is going to stop, and now I want to add another the input, and I wanted to connect it to the, let us say, input number 6. Assume that in the 6 we have connected the high level switch. So level A is the high level switch, high level. It's a high level switch. So now is a statement. Again, we need to say the statement correctly. When the stop button is pushed, or when the high level comes. When the stop button is pushed or high level comes, if any one happens, then we want to stop it. So in that case, same thing, like you can go to the, or you can pick up, select the OR gate. You can put the OR gate now. You connect the wire between this. I connected the wire. Now take this wire to the stop. Is a reset. So now with this logic, the green color push starts, level low, the high level, oh, so high. Okay, this is a low level. I'm sorry, like small confusion. Like this is a low level, not a high level. It's a low level. Low level, right? And the top one is a high level, because when a level becomes high, you want it to LBL. Okay. When you push the green color button, you want to start, or when the level becomes high, start. So anyone starts. Then the same statement, when you push the red color button, stop. Or when level low comes, you stop. Right? So it's a combination thing. We can test it now. We can click on here and go for a simulation. Right. Let us say when I push and release, motor is running. If the low level comes, I'm going to make a low level. So when low level comes, it stops. That's it. So it's gone. Now, let us say when high level comes, is running, motor is running, and then when the low level comes, again it stops. So normal starts, push button start running, and the push button stopped. So it's kind of like we tested all the different combination, like normal start stop as a home, and automatic start on high level, and automatic stop on low level. All the combination has been tested, and that's it. So like say, like for your home, like generally when you say you have a overhead tank or whatever, if you wanted to implement, so you can easily implement. You can take a small micro PLC, small one, and then you can connect the you can have the same setup, like you can have a red color button, green color button, and then you can have a one high level switch, one low level switch on your tank, and wire it to the PLC, and then you leave it. It works the way how we expect, like we need not to touch anything. Automatically when the high level comes, it goes off. Okay, for overhead tank, the overhead tank, you can say when the low level comes, you can start, and high level comes, you can stop. Any combination you can achieve. So this is a one idea which in the practical implementation on your home is possible. I hope it is clear. If it is not clear, you can ask me. So I can hold for 1 minute from now for you to ask a question if you have it. Right. So I presume that there is no further question. So we can proceed further. Um, so this is the okay. Okay, this is the logic, like what we discussed. This is slightly a different implementation, but more or less similar to the same option, same thing. Like when you push the green color button, we want to start the motor. when you push the red color, we wanted to stop the motor, and when you start the motor by green color, you leave it. The tank is filling the liquid here, and slowly the level is keep coming up, but then when it touches the high level, it has to stop. So this more or less we have already done, like the low level stop, whatever you have seen on the suction side, the same concept is same. Like whenever this is like a, you whenever this input is pushed, you set the block, and when you push this, you reset the block, and you make when this is set, pushed, or when this level comes, you can stop it. So this and this OR gate goes as a reset, this goes as a set. So it's a set, and then these two are reset. That's how it's more or less the same implementation what we have done earlier again. Right. So this is the other one. This is a little different way of implementation. Maybe we can implement and see how exactly this works. Generally, I wish to you to make it actually. Maybe like what we can do, we can give a small break now, like the 30, like let us say like a 20 minutes break now. In this 20 break, it's 20 minutes. We request to implement a program. Like it's not necessary you need to do on a software. If you have done on a software, we are happy. If not, then since you knew the logic block and everything, how you make it, you can make it on a paper. Like you can take the small piece of paper, you try to make this logic, and then you try to send a WhatsApp to me and see how many of you understand, right? Right. Let me brief you what is the logic requirement. It's a very simple only, but it is how you understand is the matter, right? So I'll make a simple one. I'll make a for easiness. We'll make a 0, because reverse logic always little tough, but I'll make it easier to understand. Right. So we have a motor here. Assume that we have a high level switch, and this high level switch is connected to the I005. When you are making the program, make sure you put the same address what we put now, because that makes your understanding is correct again. So the IO address for this I005, and then this is a high level switch, and this is a low level switch. This IO address is I007, and then we have one more, like the another level switch is like a IO address is I008. So technically, like these are the level the buttons. These are all like switches. Right. So we have a totally we have a 3 level switches to operate the whole system automatically. Just the logic requirement is this. Let us discuss the logic requirement, and then you can put the logic accordingly. And the and also the address for the motor also we can define. The address for the motor is like a Q002. Right. So the logic requirement is like when the tank level becomes high, we wanted to start the motor. When the tank level becomes low, we want to stop the motor. But when the bottom tank, when the tank level becomes high, we want to stop the motor, because what's happening, if you don't stop, then there will be a problem, like, because this water will overflow, or this will get damaged, somehow damage. So make sure the logic, correct logics. You have to make sure whether you need a AND gate or OR gate, something you need to decide correctly. But you can spell out, you can talk correctly. Like you say, when this comes, it has to start. When this comes, it has to stop. When this comes, it has to stop. So now you try to talk in like you in yourself. Make sure the you make the right logic, right? Make sure the address also you put right address, like I005, I006 for this, and then Q002, I008, and then make the block. It's not necessary you have to do only on the program. If you have done on the program side and you have tested, we are very happy. But in case if you do not have it, take a piece of paper and then you make this block logic diagram and everything, and then you can send it to me on WhatsApp, and let us see how you have made. So you can I let me leave this the program for you, just to put the block symbol and everything, because sometimes block symbol also problem. So OR gate symbol is this, RS flip flop is this, Q I, and then AND gate is like the AND symbol. So you use appropriate symbol, and then you once you finish it, just send me the picture via WhatsApp, and let us see how you have done, right? So time start now. Again, you can take time up to 11, and again 11 we start, right? Right. Yes, guys, I am back. So the time is like we are given enough time, but I did not get so far like any program. No one has sent a program. I'm not sure still. I am talking myself or you are there. I'm not sure. But anyway, I have to proceed. We need to proceed. We'll proceed now.
Sir, please share your WhatsApp number, sir.
WhatsApp number is on the text message boy, like you can see there, like an 98. Okay, if you do not see it, I can tell you now. The WhatsApp number is like 9840292883. So I'll repeat again: 9840292883. It's my WhatsApp number. It is there already in a message on the Teams. You can check from there, or like I already spelled out. So is whoever done, yes, we can send it. Otherwise, we can proceed with the next. Right. So we have given this example. Um, anyway, this example we will leave it, and then we will wait for your feedback to see how exactly it is implemented. Now we'll go for the next example. Right. So far what we have clear is like we have clear on AND gate, OR gate, and the set reset flip flop we have gone through. So, and by using the AND gate, OR gate, and flip flop in any industry, something around like a 40 to 50% of logic can be covered, right? And now, if you say about like a NAND gate, NOR gate, these are all as a very easy. It's a kind of like the same thing. Like we can see a NAND gate how exactly it works. So we can go for the simulation. See, like a NAND gate is like in a practically, if you want to understand, very easy. So I put a NAND gate. NAND gate is not AND gate. Right. So the NAND gate is a combination of and not. That's what the NAND gate. Like if you look at there by wording n and, that means not of AND gate is the NAND gate. Like as we all aware, AND gate is like all the inputs are one, the output will be high, whereas the NAND gate is not of it, means like a reverse of it. Like when all of them are one, it will be zero. In all other case, it will be one. Right. Now to understand this, we can put the both gates also. Like for example, this is the AND gate. We put a NOT gate. And then we take the examples like inputs just to visualize. We have taken two inputs. Let us connect the two inputs. It's connected the two inputs. The above one is for NAND gate. So the below one is a AND gate. Sorry. Right. So we implemented the the NAND gate and the equivalent the AND gate NOT gate combination. So you can see the top one is a NAND gate, the bottom one is AND gate and NOT gate. So as I told you, like the NAND gate is a combination of a AND gate and NOT gate. That's why in a practically. So just to visualize that, see the result we made this way, and let us try to visualize and see how exactly this is matching with what we intend to say, right? So I'm going for the simulation now, right? If you look at the results are same for the bottom and top. The results are same because, as I said, like a NAND gate it's a combination of AND gate plus NOT gate. That's what the combination. So if I make any one input on, right? So should be on, both 0 also on, 0 1 also on, like a 1 0 also on. But whereas if I make both 1, then it will be reverse. Like a, when both 1 are there, you can see the output is 0. So it's a kind of a the NOT gate. Like if you see the bottom, the AND gate is there, AND gate, and then we have a NOT gate. So this is a result of a NAND gate. NAND gate is a not of AND gate. Not of, that's what I put externally, not of AND gate. You can see the result. So this can be used in some other application where you can avoid two. Like what is the purpose of this NAND gate? NAND gate, like you can use the AND gate and not, we can achieve the same. But if you want to reduce the number of blocks, yes, you can reduce the number of blocks, so that like it will be like if the logic looks very simple, right? So this is what with the NAND gate, how exactly it works. And the other one is same formula, like I can delete the AND gate. Now we have a NOR gate. The NOR gate is the same combination of OR gate plus NOT. We can see the result now. I put the same thing because NOR, N-O-R, NOR, not of OR gate. So I'm going to put this. Right. Right. So now we made this logic. So we are going to simulate this. This is like a, you can see the results of both top and bottom is same. The top one is a NOR gate and bottom one is a OR gate and NOT. Or not of OR gate. And top one is NOR gate. So the NOR gate and bottom OR gate NOT is same. Let us try to simulate and see. So right now both of them are 0. So the result is on. So in OR gate, like any one is 1, you get output 1. and both are 0, you get the 0. So now this is the not of it, the reverse of it. When both are 0, you are getting on. So if any one is on, you get the result 0. So you can see the both works in the same way. And then I am making the other way around, 0 and 1. So you get the same result. And whereas when I make a, okay, I'm saying if both 1, the output is 1, the output is 0. And when both are 0, this is the only condition where you get an output. Where in OR gate, only this condition you won't get the output. So it's basically like it's a not of OR gate is the NOR gate. So now what we have seen is like AND gate, NOT gate, NAND gate, OR gate we have seen. So we have multiple gates also, like a XOR gate also is there. So it's a kind of like all of them are in combination of different the inputs and outputs. So but with this the basic gates like a AND gate, OR gate, set reset flip flop, these three are major role. Obviously the AND gate, NOR gate, XOR gate, these are all like additional gates, but still that gates function you can achieve by the basic gates, right? So this is what with the gates like see, as long as you know these kind of gates and you have the applications note how the application can be made. Actually, see, we have a multiple examples to do. So but it looks like we did not get any reply from you. So like we are not sure whether like you understand or not. So that's why like we are limiting the examples. So and then we go to the
Sir,
next.
I sent to you, sir.
Say again, boy.
I sent to you, sir.
All right, great. Yeah. I have seen like I think like only one gentleman has sent this. I am happy that at least out of multiple, at least one worked correctly. Yes, green, and when a high level comes, okay, I can show you like what he sent just for right. So the one what you see on the screen is the only one which I got it from your guys. Right. Let us review the logic how exactly it is implemented. When the green color is pushed, you wanted to start. That is correct. So maybe like here you need to make a motor. You need to make a RS flip flop. The top one is S and bottom one is R. Okay, you understand. That's why you did not put it. But just for a representation, it can be for more clarity. You can put a word S on the top and R on the bottom. Just for it's a note only, but the logic is okay. The whenever you push the green color, you have R gate, yes, and then it starts. Okay, correct. And when the high level comes, you want to start, correct. Okay, that comes and start, right. Then when the low level comes, you stop it. That is correct. And when the red color push button is pushed, again you stop it. That's also correct. This output tank high, when the output tank high comes, you stop it. Yeah, that's correct. So it is a very correct, appropriately done. So this is it's excellent. So appreciate that doing a one logic very correctly and very precisely done. So we appreciate you. I'm also happy that the training what we have given did not go waste. Very happy. Oh, Right. So, guy, like, we appreciate you. Like, this is a really very good implementation. We are happy. Right. Um, so now with this, like, the more or less we have done with the gates clearly. Now we move on to the next topic. So today we wanted to go to the timer. The timer we want to cover up, and we wanted to implement a few examples too. And let us try to review and see how exactly the timer works. Right. Right, guys. So now we try to go for the on delay timer. The next function is a on delay timer. The on delay timer is a okay. If you want to understand very correctly by the word on delay timer, in a on you make a delay. That's a on delay timer. On delay timer. So let us say, just for example, if you want to brief it, right? Assume that you have a safety system in your home. Just for example, right? You have a safety system in your home. You wanted to activate the safety system, and you wanted to go out of your home. This is your requirement. But when you activate the safety system, you being inside the room, the safety system will see a human movement and will make a noise immediately. If that is the requirement, like what will happen when you are inside the home, before you lock the your door, inside, if you activate, once you activate, the safety system will see you as a some human existence, and then make the alarm immediately. How to avoid this? So we want to avoid once you activate this system for a 30 seconds, for example, for a 30-second, this system should not work because you are inside. You have to lock the room and you have to go out. Once you go out, when it activates, no problem because nobody is there. And then if anybody enters into the building, then it makes the noise. That's how it's supposed to be. So now what we want is like technically what you want to achieve is you wanted to make a delay. You want to make a delay in the activation of the system in on, like you are pushing now, but now that equipment should not go on. It should take some delay and then it's supposed to become on. So for this purpose, this is the exact application where the on delay timer is used. Right? Hope it should be clear. The concept wise, the concept is like whenever you activate anything, it won't go activate immediately. It takes some time and then it will activate. That's what the actual requirement. Now, just to visualize that, we can see, we can implement that and we'll see the execution, right? Let us say I am taking a one input and I have a output also. Assume that this input is my remote system. I have a remote in my hand actually. Once I activate my remote, I don't want this to be on immediately. Like the same safety system only. The safety system in a home, when I push it, it should not come on immediately. But I wish to come on in a time frame after 30 seconds. That is my requirement. So in that case, what I do, we can scroll down. There is a on delay timer. You can pick up the on delay timer. You can push it here, and then you connect this input here, and then you connect the output to the your PLC output. Like we can say anything like system also, any design actually. So now what is happening with this implementation? When I switch it on, it won't switch on immediately. It goes to the on delay timer. This on delay timer, you can define how many seconds or how many hours or how many minutes you want to delay and then make it on. You can define. So you can double click on it. When you do a double click, it gives the option either you want to set it as seconds, minutes, hours. What do you want to set it actually? So I want to go with the seconds. So I want to activate in a 10-second. I want to activate this. Is my requirement. Okay, I made a 10-second. Right. So I have my remote. When I push it on, then I have my timer, and this timer starts running after getting the input signal. It starts running. It after 10 seconds, it will activate. So this is how the same circuit is inside the any safety system. This is how it will activate. So that way you get enough time to go out of the building, right? Okay, so let us try to simulate and test it. So I'm going to go for the simulation. I'm going for simulation, right? So now I'm going to switch it on and see the result. So I switch it on. Look at the output. Output is off, but you can see the timer value is running. 6 seconds, 7 seconds, 8 seconds, 9 seconds, 10 seconds. So after 10 seconds, the circuit board become on. Once the circuit board become on, then you get a time to close your room, and then you would have gone out. By the time the security system is on, you are already out of the building. So from that time onwards, if anyone comes inside, it will make a noise, right? So this is a small circuit. What exactly the small logic requirement? What is already input into the all safety system? That's how it is designed actually, right? Hope the on delay timer function should be clear now. So just to recap, and the on delay timer, when you make it anything on, it won't become on immediately. It makes a certain delay, what you can define always, and after the time, the output become on. So this is the concept. So I hope this should be clear. I can give a 1 minute break, just to see, like, in case if you have any question, you can ask me on this topic. I can repeat, or I can tell you, I can explain again if you wish. So I'll wait for 1 more minute to see if anyone has a question. Okay, so I presume the all of them are clear on the concept, but I have a one more question. Somebody has asked, like, how can we avoid alarming when we enter into home, right? So generally what they do is, like, when you are before you opening the door, you have always a remote. So when you push it, then the system will disable by itself. So we do not require anything like a special thing. Only for the going out time we need, because you will be inside, you will make it, and then you go it. Otherwise, like, you can do other way also. Like sometimes, like, you can set everything, make ready, and then you can go out of the building, and then you activate also. Okay, that time also you don't require the on delay time. Like for example, like, you set up everything and then clean and everything, and whatever you wish to do in the home, you make it, and then lock the door and go outside the building, and then you activate. But only the problem here is, like, the see, generally, like, since it is a home security system, you always wanted to make sure the system is activated, and you are confirming and leaving. That's how, like, normally what they do, they used to push the remote. Once you push a remote, in the safety system, there will be LED which got the information. The LED glows, but still the system is not activated because there's a timer running. So generally when you activate and then you look at the LED, make sure the system is on because you are going out, it has to work, and then you lock it and go out. Whereas switching off is not priority, because like if it is not working is issue when you are out, but if it is working correctly, it's not an issue. So when you're coming to the building, it's not an issue. Like you can do from outside also, but generally like activating after closing the door, there is some suspicion. Like even if the machine is not working also, where you would have pushed, you may be thinking it is working, but it may not be working. So that's why like normally what they do, they used to have the remote, they push it by looking at the safety device, and then the security device becomes on, and then they confirm, hey, okay, fine, the security is going to become on because it's become light is on, fine. Then they will rush out, go out. So that way at least you made sure that system is on. But when you're coming inside, it's not an issue, because like anyway you are owner and you come in, when you push it, it go off. So off is not an issue actually, right? But if you without switching off, if you enter, yes, obviously it makes the alarm, right? But the remote you have it. You're supposed to have the remote to switch it off, right? So I presume that the timer on delay timer, it work, the concept understand very well. It's okay. Now, based on this concept, we can see the few process example, and then we will try to write a program for those process example. That way, see, like right now, what we understand is the very raw theoretical form we understand. Like theoretically, like when the input is comes, and then after 10 seconds, the output comes. This is like a very theoretical part, but only we visualized in a practical way. Whereas we want to visualize in an application point of view, so that like we understand how this is being used in an industrial environment, right? Fine. So that's what we are going to discuss now. This is one of the example, like where we have a tank, and that tank, like the liquid is pumped out by the one pump, and this pump will take out the liquid from the first tank and push the liquid to the another tank, maybe like for transfer or for maybe distribution or for any utility purpose, right? Now here the question is like when you start it, when you push, yes, obviously it will start, but sometimes what happen, like there the pump goes airlock, like something get locked, air will get locked, the motor will run, but you don't get a water coming out. So if that happens, what will happen after a while? Maybe if you are starting now, and then if it got airlock, and then it's running for 1 hour, then what will happen in the 1 hour? The pump will get slowly heated up, and then it will damage. The coil will go off. Then you lose your pump, and then you need to take it to repair and pay money, time loss, everything. So for that reason, what they do is like they put a flow switch outside the pump outlet. They put a flow switch. The flow switch, what happens, like when there is no flow, when the pump is motor is off, there won't be any flow. So the flow, like you can see the flow switch has got in the bottom. There is a flapper bottom. The flapper, it will be in a straight position, so that like this switch will give a 0. That means there is no flow, right? The moment when it starts the motor, if the liquid comes out, the liquid comes, and then the liquid push the flapper on the right side, and then it go out of the I put a bigger flapper. It's not a bigger flapper, it's a small flapper, and the line is obviously bigger. Line is obviously bigger. So what will happen, this flapper will be moved on a right side direction. It moves it up, and then the water goes down. So when that flapper gone in the right side, then this flow switch, a micro switch will be activated inside the flow, and the micro switch will give a 1 because the circuit will close. So whenever the circuit close, that means there is a flow exist inside the pump discharge. There is a flow. That is the meaning of it. right? So if there is no flow, for example, I did a start, motor is running, and there is no water coming out because of the airlock. Then what will happen? There is no water. Water won't push this. So since water is not pushing it, the for the flow switch will give a zero. That means it is saying, hey, there is no flow, but motor is running. So you can take some necessary action to stop it, right? So this is the actual program. So what the program what we supposed to implement is, when I push this start, the pump has to start. When I push the stop, the pump has to stop. This is a normal logic, like what you have in a home, start and stop. And what we have additional here is, when you give a start, right, for a 10 seconds, for a 10 second, you don't see the flow switch status. But after 10 seconds, this flow switch has to give a 1. If it is not giving, it stops the motor by itself. Okay. Now your question could be, why 10 seconds? Because when you start a motor, you cannot get a pump immediately. Like in your home, if you have the motor, once you put a motor, you don't get the moment when you switch it on, you don't get the water coming up immediately. It takes a little time because it has to shuck and it has to push it out. So that is why we are giving some time for the pump to work, to see it can push it out. For a 10 second, if it is not giving, that means there is some problem in the airlock system, or maybe the tank level is not there. See, it's not necessary we have to go with a level switch to find out the low level. By using a flow switch also you can find out. The flow switch advantage is like a two advantage. One is, it can find out indirectly there is a level or not on the tank. The other one is there any airlock inside the pump? These two can be identified indirectly by the switch, right? Okay. So now, basically, when you push the start and release, the motor has to run. And when you push and release the stop button, the motor has to go stop. And the flow switch, after you start, within 10 seconds, it has to give a 1. If it is not giving 1, then we have to stop the motor. Hope the logic requirement what we supposed to implement is clear, right? So now let us try to implement this and try to visualize whatever we discussed, how we are going to achieve in a PLC environment, right? So right, let us go for the, okay, let us, before we go here, we will try to define the addresses. So I'll say I001 for this start switch, and then I will say I002 for the stop. I will say when I push 1, when I release 0. And then this one is like a, make a I003 is the input 3. So we have 1 is for the start switch, 2 for the stop switch, 3 for the flow switch. And then we have a output. The output we, let us say, Q001. Q001. This is the my motor output. Right. So we all understand this one is a push button switch, because we are pushing and asking the sending information to the PLC start. So the PLC is getting information. Getting means input. In the same way, PLC is getting information from a stop switch is the input. And also the PLC is getting the flow switch activation. Again, this is a input. So we have got a green color input, red color push button input, flow switch input. We have 3 input, and we have a motor output, because the PLC has to give a command. PLC has to give out a command to the motor. Since it is giving out, supposed to be output. So we have a 3 input and 1 output. Let us try to define and then try to configure the logic. Right. So I will try to delete this, the whatever we have it here, and let us try to do freshly. So now I'm going to the top, taking the first input, right? And this is the green color, red color, and flow switch. And if you want to connect to the, if you want to change the address, you can always change. Like now by default, this address is 1, so for me it's okay. And then stop is address 2, and then flow switch address 3. So just will give a name is a green, and this button is a red, and this one is a the flow switch, right? So address 1 green switch, address 2 red switch, address 3 flow switch. So we have connected that. That's what we connected on the like what we have shown you, the PLC and wiring. There's a physical wiring done. So we are assuming that is how it is connected. And we have a the output, motor output. So we have a motor output. Assume that this motor is connected on the channel number 1, output channel number 1. So and this is a pump. Okay, given the pump. Okay. So now, since we have already got some knowledge on the set reset flip flop, we know how to make the logic. So I'm going to use the same logic like a latching relay. I'll put there. Whenever I push a start, I wanted to start it. So this is the like normal start logic. Whenever I push the stop, it has to stop, right? So these are the logic which we already knew with the previous examples. Like pushing a green color, set it via the set reset flip flop, and the output remain high and it is running. And pushing the red, reset it, and switching off the motor. Now we have the flow switch. Now the requirement is like when the input is on. That's what we wanted to do it, right? When the input is on, we want to start a timer, right? Because you're not going to, when you're going to start the timer, that's very important actually. When the motor started, we want to start a timer, right? I'll take a timer. So on delay timer, I'll take it. Right, I'm going to connect this, right? When once the motor is started, we want to start the 10-second timer. Like I'll go here, I will type it 10 seconds for 10 seconds. After 10 seconds, this gives a 1. When this gives a 1, that time what we expect? We expect flow must be 1. If the flow must be 1 means there is a flow. There should be flow. If there is no flow, then we stop it. That's what the logic, right? So when like that means like just if you wanted to say a statement, if you push the stop, it has to stop, or after starting 10 seconds later, if the flow is not there, also should stop. You just see the statement clearly. Stop, pushing the stop has to stop the motor, or after the 10 seconds after the start, if there is no flow, also should stop. So it's a kind of a OR gate. Either stop should stop, or 10 seconds later, if there is no flow, also should stop. Right. So we understood there's a OR gate is required. That is a must. So what we do is like we understood some OR gate is required on this area. So we connected the OR gate. Right. So now what we wanted to do now is like when the timer is done, we get a 1, right? When we get a 1, when we get a 1, what we expect is this has to give a 1. 1 means flow is there. If 1 is not there, then we want to stop it. So let us say when this 1 comes, this also should be 1. Then only we can allow. Otherwise, we stop it. So let us take a AND gate. Okay? AND gate we take, we put here, we put there. So what is the meaning of it? Like when the timer is done, this timer is done, it is going to give a 1. 10 second after the pump is started, 10 second later, this gives a 1. Right. By that time, this is supposed to give a 1. If this is giving a 1 and if this is giving 1, then we don't stop it. So generally, like when you give a 1, 1, the output will be 1. When I connect the 1 here, then when the OR gate 1 will come, it will go and stop it. Right? But that we don't want actually. Basically, what we want to do, we want to invert it. Because you can see here. So now what will happen? When both are 1, so this will become a 1, 1. It will become a 0, like a 1. The output will become 0. So when it's 0, it won't stop. So what I'm going to do, like I'm going to do the wiring. This way. Right. So then the output will go from here. Because this is normal, like any OR gate, like either the stop has to stop, or when the input after the timer is done, if there is no flow, then also we want to stop it. These are two conditions. So it's all like all put together, like this all section, whatever we selected, there's a one condition, and then stop alone one condition. So either the stop has to stop, or the once it is started, like once you are given a start command, 10 seconds later, if the flow is not there, also we wanted to stop it. Right. So this is what like we wanted to implement. So now we can test it. This I'm making the clear gaps and everything so that you can understand better. So I'll make this one slightly higher. Right. So you can make the other way around also. Like see, I'm going to make in a easiest way. I will do slightly, instead of putting the NOT gate on that side, I'll put this side. So it will be like readability is less easy. Right. And this should be, I can put like this. Oh, sorry. So right, this way. Now we can simulate and see. Slowly we'll understand. Actually, slowly we'll understand. Let us try to go here. Simulation. Right. Now I will make it off. Now we have the green color button. Sorry. Okay, we have a green color button, and then we have a red color button. We have the flow switch here. As a simulation, when I switch it on, right? When I switch it on, the pump has to go on immediately. Then, once it is gone on, the timer will start. You can see the timer value bottom, what you're seeing, 0, 0, it starts rolling. It's a 10 second. We given a 10-second timer. 10 second, after 10 second, this will become on. When this become on, by the time, if the flow switch is giving a 0, that means there is no flow. Since we have a NOT gate, it will stop immediately. Let us try to simulate and see. I'm giving on. I given a pulse. You can see the timer is running. After 10 seconds, it's going to become on, red color line. And the output also become red, and then this will go off. Pump will go off because the already pump gone off. Just maybe like we can increase the time, maybe 30 seconds, just to visualize better. So I'm making on. Now the motor is on. So since the motor is on, you can see the timer is running. After the motor start, the timer is running. So it is giving some time for the pump to send the liquid out, but still the flow switch saying no flow. Now also saying no flow. So now 22 seconds gone actually. Still no flow because it's giving 0. Since it is a no flow, after 30 seconds, this will give a stop command. So it is given a stop command, pump is stopped. You might be able to see the on LED coming off because it is a very fast scanning. You don't see that because it's going off immediately. It's a millisecond goes off. Right. So now I'm going to start now. Now I given a start command. Motor is running. Now if I give a flow switch as a flow healthy, let us say the flow switch saying yes, there is a flow. So now what will happen? It won't stop because I have a flow available. So now what we are doing is we are blocking by NOT gate. This gate will never execute. You can see this output will become okay. Like the on delay timer, after 30 seconds, you can see it becomes on. So you can see it become a red color. It become on. On means red color actually. But now, because the flow switch showing flow meter flow is there, it is not starting, not stopping, keep running. But anytime during running, for example, like the flow is showing again, hey, there is no flow, then it stops. Now, if I make there is no flow, then what will happen? Immediately this output become on. So both become on. So this output also become on. In OR gate, either you stop or the stop coming from a flow switch also can stop. So then this become on. When once you given a reset, then the motor goes off. Right? So basically what we are doing is like we are giving a 30-second for a pump to start. However, but still what we can do, if you want to stop, you can always stop it. Let's say I want to stop it. Yes, you can stop it. Right? Flow switch is like then obviously the flow switch won't give a flow, then it becomes 0. Right? Again, one more simulation. So when I make it on, the motor is going on. If my flow is not established, that means the pump got airlock or the pump suction tank level is 0, there is no water, then this flow switch won't show on because there is no flow. So then there is no flow, the motor can run for 30 seconds, make sure it can deliver. If it is unable to deliver, then what it does, then it will simply switch it off. So now what happened? It's like I left it on. That's why it's again become on. I pushed on and released. Again, motor is on. It is waiting for 30-second timer to expire. It will allow 30 seconds. Within 30 seconds, it has to become the flow switch has to become on. If not, then it goes off. So I am not making flow. There is no flow. Let us see. It's switched off. So it switched off because there is no flow. Then again I am starting it. Now again timer is running. Now this time I am making flow is there. Flow exists. So since the flow exists, now even the system is really there is a water exists and the pumps are no water airlock and everything looks to be perfect. That is why it has to keep allowing the motor. It should not stop. So let us wait and see after 30 seconds what happens. Right, now 30 seconds is finished, but still the motor is running because the flow switch saying there is a flow. Then there is no need to stop. The system is healthy. So, but during the running, for any time if there is no flow, then it stops the motor immediately. I'm going to make a no flow now. There's no flow condition, so it stops the motor immediately. Right. So this is like this people used to say the pump dry run protection, like a pump dry run protection, because they don't allow the motor to run dry without water, because that will destroy the pump by spoiling by overheating and then spoiling the contact coils inside, and then it will damage, right? So this is to protect the motor. This is the logic how it works. So now I hope it should be clear. It should be, and it is understandable. But in case if you did not catch up correctly, if you have some doubt or query, you can always ask. So we are going to stop now for 1 minute for you to ask any question if you have. Yes, if you have question, you can ask me. That's not a problem. It's like you can talk now. Guys, it is not necessary like you need to speak in English. Maybe it's like somebody may be thinking like, hey, we cannot talk in English. We won't talk in Telugu. Telugu also welcome boy. Nagu మీరు మాటలు తెలుసు. So you can tell me. You can talk in Telugu also. I can understand very well. And also I can talk in Telugu also to some extent, but not maybe perfect. But I'm sure I can explain you in a better way. You can talk in Telugu also if you wish to ask questions. I am okay with anything. So I presume that there is no question. It looks to be everybody understand clearly. The concept looks to be clear. So you can always ask a question. Like say there is a three option. You can talk to me, or you can type there, or you can talk in your own language. Also, problem it's not an issue. That's not a. I can easily understand your query and explain to you if you wish. Right. So now we proceed for the next one. It is a like a off delay timer. So we will explain you the off delay timer, and we make a one example, and then we close the day today. So we'll go for the off delay timer now. So I'm hope that this the on delay timer function, on delay requirement is clear, on delay function in a process implementation also clear. So let us try to go through the off delay timer, and then try to implement a one example, and then we understand well actually, right? So by the word off delay timer, so basically what it does is in off it makes a delay. That's it. So very simple. Like in off, it makes delay. For example, let us say you are in a you have for the best example is like a your staircase lamp, right? So assume that like a you climbed up on the staircase. Just for example, when you climbed up the staircase up. Now, after you had a visit on a terrace, you are trying to come down to your home. While coming down, while going up, let us say you switch on the light. Light is on, but while coming down, you want to switch it off. But remember, like you are on top. When you switch it off, you lose the light, and then you cannot come down. So when you switch it off, it has to go off. but not immediately. 10 seconds later, because within the 10 seconds later, you would have reached bottom, and then it can go off. So basically, what we have done, you make a switch it off on top. You already switched off on the top before you step down, but the light don't go off immediately. It takes a 10 second. It gives a time to you to come down from top to your home, and once you come in, then the light goes off. So this is the function of the off delay timer, and let us visualize the function itself, how exactly that works. Right. Let us say I have a switch. Let us say I have the off delay timer. Let us say I have output and connecting the input of delay timer, and then this is the right. Now let us check. Okay, let us say this off delay timer, you set the value as a, let us say 20 seconds. That means when my input is off, the output remain on until the 20 seconds and then goes off. In off, it makes a delay. Let us check, visualize this. Whenever I am making on goes immediate. There is no delay, nothing, because it's an off delay timer. But let us say you are in a terrace now and you are trying to come down. When you are coming down, you are going to switch it off. But when you are switching it off, I say I switched off. Now you are walking down on the staircase, but still your light is on because you wanted to come down, you wanted to see the staircase clearly. And after 20 seconds, you would have reached home already. So now no need to keep the light on. The light goes off by itself. Right. So now the light goes off. So this is the application where off delay timer can be used. So the on delay application time, we have seen the security system. Before you leave, you want to switch it on. After 10 seconds, it has to become on. For the off delay timer, you are in a staircase, you are trying to come down, you wanted to switch it off, but it should not go off immediately. It has to go off after 20 seconds. That's how it has gone off, and then now it is, you are already inside the home, no need to keep the light on, so the light gone off, right? So this is the utility of the off delay timer, how exactly it's supposed to be implemented. Right. So what we understand right now is like the theoretical the functioning of that specific off delay timer, in a practical, how exactly this is working. That block alone we have seen. Now we can think of the application, how this application can be made using the off delay timer. Right. So now let us take the off delay timer. I maybe I can hold for a 1 minute just to understand, you understand this concept well, and if not, you can ask a question. So I'll wait for one more second. If you have a question, you can ask me. Right. So I presume there is no question. So I understood everyone clear on the off delay timer. So now I'll explain one example, and I'm not going to implement it by now. I will leave it to you, and you can try to implement, and and you can send me the picture, like either you can the graphical format or the implementation, whatever. So by tomorrow when we are starting the class, maybe we can review whoever sent it, we can try to explain the same and try to visualize that same thing, and we will see how exactly it goes, right? Fine. So now I will give you one example, and this example is supposed to be here, but it is not there. Right, fine. Let us make that example now for you. Right. So I have motor. I have a turbine also. Um, One second, boy. Right. So we have the pump, and this pump is a cooling pump. We can say it's a cooling pump, and we have a turbine. Like let us take a turbine. The turbine is like the turbine symbol is okay. Okay, let us take this turbine. Right. So this is a the turbine, and generally what they have is like the turbine while it is running, it needs a cooling system. So the cooling, you can say the cooling system goes here, and then we had a tank. And then this cooling liquid comes back to the tank, and this cooling liquid is taken out from the motor like this, and this is a turbine, and this one is a lubrication oil. It's a lube oil. Right. So basically, the logic is like I can see this way. Let's say we have a button. We have another button. Let's say this is a start, and address is I001. And let us see. Generally, it used to be in a color of green. You can say green color, and then I can say this is a red color. That is a stop. The address is 2. And we have the turbine. The turbine command is, you can say, Q001. And then the lube oil command Q002. The reason why I give I here is like I is because there's an input start. You are asking the PLC getting input, getting this information from the switch to start, getting the input from the stop button to stop it, and then from the PLC, this motor gets a start command to start, and the same way the turbine gets start command to start, with a Q001. So now the logic requirement is like when I push the start button, the Q001 and Q002 start immediately, right? Both two output it has to start, and then when I push the stop, the Q001 has to go stop, but whereas Q002 should go off after 30 seconds. The reason why is when a turbine is running, turbine generally makes a lot of heat because it is running on the heat system, like a steam system. It needs to be cooled down. Otherwise, what will happen? It is in a hot. When it is hot and stays there in a one place, the blades are in a one position, and then there is no movement, and it's a very hot. What will happen? The shape will change actually. Then next time when you start, it rolls in a different way and vibrate, and it will damage. So for that reason, what they do, any turbine when they stop it, they will run the cooling system for 30, generally 1 hour they used to run. But okay, in our example, we run for maybe 10 seconds or 15 seconds. But in practical life, any turbine when they go off, the lubrication system or the cooling system, both are same name, same application. This system has to run for 1 hour to continuously cool down the turbine so that there won't be any mechanical damage to the system, right? That is the reason for running the system, right? So the logical requirement is very simple. Starting the pushing the start button has to start the Q001 and Q002, like same set reset to the flop, and then stopping the button has to stop the Q001 immediately, whereas Q002 should stop after, you can say, 10 seconds after this equipment stops, right? The logic is clear. Whenever you start, starts both. Whenever you stop immediately, whereas Q002 should stop 10 minutes, 10 seconds later. Once it cools down the system, you can go off, right? This is the logic we supposed to be made actually. So now this you can take it as a the example to you. We have already demonstrated the off delay timer, how it works. So, and also we have seen a one example for the on delay timer. So use the previous examples and then use the current off delay timer, what the example what I gave it to you for the staircase coming down. Use that, those two combinations should help you to make the logic for this. And then once you make a logic, you can send me via WhatsApp. So I got a one WhatsApp today. I'm happy. So let us see how many of you, like, see, I'm sure the progress will be slow. Progress cannot be immediate. So at least I have seen a one progress. Hope today I can see furthermore the progress, and we all can meet by tomorrow 9 o'clock. So you have plenty time. Yes, you can play a lot, but you use me a few minutes to work on it. You can talk to your friends or whatever and try to organize and see something you can try, right? Because this is a very essential. This is like really to help you, like when you come out. Yes, when you attend an interview, yes, it will somehow it will help you if you try it out, right? Right, guys. Thanks, and see you by tomorrow 9 o'clock.